Welcome back to Sumantra Codes. This is day 12 of our series, and today we are going to learn about modules and packages. So a module is a file that contains Python codes such as variables, functions, classes, etc. that can be imported and used in another program or a file. A package is a collection of modules that are organized in a hierarchical structure using folders and subfolders and have a special file called _init_.py that indicates the folder is a package. For example, the math module is a file that contains various mathematical functions and constraints such as math.square-root, math.py, etc. And the numpy package is a collection of modules that provide various numerical and scientific computing features such as numpy.array and numpy for linear algebra, which is called as numpy.linalg, etc. Modules and packages helps to make the code more modular, reusable, and maintainable by organizing the code into separate files and folders and avoiding name conflicts and duplication of code. Modules and packages also help in extending the functionality of Python by providing access to various features and libraries that are not built into the language, such as web development, data analysis, machine learning, etc. To use a module or a package in Python, we need to import it first using import keyword of from import syntax. The import keywords allows us to import a module or a package and use its content by using a dot operator and the name of the module or the package. For example, to import the math module and use one of its function, we can write import math. And to use its square root function, we can write math.sqrt square root and the value of the parameter and then run it. So you can see that the math module is extending the functionality of Python by providing you the functionality to calculate the square root of a function. The from import syntax allows us to import scientific contents from a module or a package, such as functions, a class, a variable, etc., and use them directly without the dot operator and the name of the module or the package. For example, to import square root function from the math module and use it directly, we can write from math import sqrt, and then we can just call the square root function directly. We can also import the pi constant and print pi. So over here, we have a defined value of pi in the math module. We can also use from import syntax to import multiple contents of a module or a package by using comma separated list of names or a star to import everything. So to import everything from the math module, we'll just write from math import star. Now again, if we run this, the program will get executed. However, using the star to import everything is not recommended, as it can cause name conflicts and confusion and make the code less readable and maintainable. It is better to import only contents that we need, or use the import keyword with dot operator to access the contents of the module or the package. So Python comes with a large number of built-in modules that provide various features and functionalities that are not part of the core language, such as mathematical operations, random number generations, date and time manipulation, etc. To use a built-in module, we need to import it first using import keyword or from import syntax, and then use its contents such as function, classes, variable, etc. So let's see how to use some of the built-in modules and their functions in Python, which will extend the core functionality of the Python language. We have already seen import math. Let's just repeat it once more. Print math.sqrt, let's say 36. So over here, we are using the math module to calculate the square root of 36. Similarly, there are other functions in math module that we can use. For example, we can print or calculate sine of pi by 6. So we can have pi from math.py and 6, and we run it. So we'll get 0.499999. Over here, we have used math library's sine function to calculate sine of pi by 6 radians. Similarly, math library has functionality to calculate factorial of a number. So we'll see that example also. So we can see over here, we have calculated the factorial of 5, which is 122. Okay. Now let's go on to another library, which is random, which helps in random number generation. So let's just import the library first. And then we'll use function random.randint with parameters 1 and 10. So this function will provide a random integer between 1 and 10. So let's just print it and see the output. So it's 2. So every time we run it, we'll have a different random number generated between 1 and 10. Similarly, let's just comment the print code. Similarly, we can use random to generate a random floating number between 0 and 1 using the random function. So if we print it and run it, you will see a random number between 0 and 1 is being generated and printed to the output console. Let's see one more example of random. We define a list. Let's say 1, 2, 3, 4, 5 and just call random.shuffle and then print my list. Let's just run the code again. You can see order of the list content every time we run it. It's getting changed. Let's just comment this. And now we'll see some example of the datetime module. This is also one of the most used module in Python programming besides math and random. So if you want to know the current time of the system, we'll use datetime. So it's a bit confusing. Now to get the current date and time. So if we print the value of now, we'll see the current date and time of the system. We can also use date and time module to format date and time in a specific way. So we can say now.str format time. We can write, let's just say we'll give the format specifier %year, then %month, then %d, then %r, %m, and %s. And now if we print it, you will see that we've got the time in the specified format. If you want to change it, let's say month, year, and run it, we'll get a different output. So as mentioned earlier in my previous videos, you can get details about this str format time function using the help module, or you can search on Google and get the detail about the format specifier. One more thing I want to show that is used generally in programming is to calculate the difference between two dates. So let's just create a date object first for a specific date. So let's define my date as datetime.date 2024, let's say 5/22, and let's just print it, my date. So you'll see this is showing 22nd May 2024. Now we'll use date and time module to calculate a difference between two dates. So let's define a variable diff, which will give the difference between my date and now.date functionality of datetime module. Let's just print the diff. You can see the delta is -97 days. Similarly, you can calculate the delta in seconds, hours, and minutes in any specified format you want. Next, we talk about third-party modules. Third-party modules are modules that are not built into Python, but are developed and maintained by other developers and organizations and provide various features and functions that are not available in built-in modules, such as web development, data analysis, machine learning, etc. To use a third-party module, we need to install it first, either using pip or conda, and then import it using import keyword or from import syntax, and then use its content such as functions, classes, and variable. To install third-party modules in Python, we need to use a package manager such as pip or conda that can download and install the modules and their dependencies from online repositories such as PyPy or Anaconda. Pip is the default package manager of Python, and it comes pre-installed with most Python distributions. Pip can install modules from PyPy, which is a Python package index and the largest repository of Python modules. Conda is another package manager for Python, and it comes with Anaconda, which is a popular Python distribution for data science and machine learning. Conda can install modules from Anaconda, which is curated repository of Python modules, as well as from PyPy or other sources. Now let's delve down into detailed steps to install third-party modules in Python. So we'll first do it using pip or Python package installer. Pip usually comes pre-installed with Python. To verify pip is installed, open your terminal and type pip version. If pip is installed, you'll see pip version information. If not, you can install it using the following command: python -m -ensure pip --upgrade. Alternatively, you can download and install pip manually from official site. For that, on Google, type pip download and follow the official documentation and step mentioned in pypy.org project pip. To install a module from PyPy using pip, use the following command: pip install module. For example, if you want to install request module, so we'll type pip install request. So it will check, and it looks like in this Python environment, I have already installed request version earlier. If request wasn't installed, it will automatically install the request module. To check whether request module is installed and working in Python, open your editor and write import requests and then print request.version and run it, and it will show the installed version on the output console. Over here, the pip version which is installed is 2.32.3. To uninstall a module, we have to use pip uninstall and the name of module, for example, requests. So this will uninstall the request module. It will ask you to proceed yes or no. I'll type yes, and it has successfully uninstalled the request module. Now I'll again install the requests module. Now it has again successfully installed the request module. Another way of installing Python modules and packages using Conda or Anaconda package manager. If you don't have Anaconda or a mini Conda installed, download and install Anaconda from Anaconda's official website. So on Google, just write Anaconda Python and you will get the link to download the Anaconda distribution, which is freely available. You may require to sign up to download the Anaconda. However, there is a stripped down version of Anaconda which is known as mini Conda, which I prefer because it is lighter and provide most of the machine learning and other important library pre-installed which are required for advanced computing functionality. So just type mini Conda installed on your Google search bar. You'll see a link and you can go over there to download the mini Conda installer based upon your OS requirement, whether it's a Windows or a Mac or a Linux operating system. Just click on the mini Conda download, save your exe and run and install it. I prefer mini Conda over Anaconda because it consumes very less space. Once your mini Conda is installed, we'll open the mini Conda prompt or an Anaconda prompt and verify and check the installation of Conda by typing Conda version. Again, to install a module from Anaconda repository, you will use Conda install and the name of package, let's say numpy. So it will check the dependencies and other stuff, and it will start downloading the repository from the environment and will proceed yes, and it will download all the package required for numpy. Once the installation is done, the transaction is executed and we have numpy installed or other package installed in our Conda environment. So basically, Conda can also install packages from PyPy using pip also. To do this, activate your environment and then use pip within Conda. So pip install request will also work from conda environment. It has ran the pip command and checked that request is already installed in this Python environment. Similarly, you can uninstall any package or module using conda remove and the name of the package you require to remove. This command will remove the numpy from the conda environment. So these steps cover the essential for installing and managing third-party Python modules and packages using both pip and conda. Now let's see how to use some of these third-party modules and their functions in Python. So we have already installed request. We'll first call import request. So Python request is a library for making HTTP requests. It provides an easy to use interface that makes working with HTTP very simple, which means it simplifies the process of sending and receiving data from websites. So for example, in request module, we have a command called get, which will make HTTP request to a web page and return a response. So over here, if we'll write https www.python.org, it will return a request to a web page as a response. So we'll just assign it into a response variable and we'll print response. We're getting a response object with 200. So we can use the request module to get status code, headers, and content of the response. For example, we can print response.status code. Then we can print response.headers. And finally, we can print response.content. If we run it, we can see we have received 200, which is a successful return code, connection, status code, and then we have the complete HTML content of python.org website. This is not an introduction or detailed explanation of the request module, but it's just an introduction to how you can use other third-party libraries that extend the functionality of Python. The next we can check is numpy. So we have already installed numpy. So we'll just import the numpy. So over here, you can also use the as keyword to assign an alias to a module or an object. This allows you to use a shorter and more descriptive name for the module or the object. Generally, numpy numeric Python is imported as np. So numpy is a Python library used for working with arrays. It also has functions for working in domain of linear algebra, Fourier transforms, and matrices. So let's see few examples of numpy functionalities. So to create a numpy array, let's say my array, we'll use np.array and create an array of size 5, and then we'll print my array. If we run it, it will create the numpy array. We can use numpy module to perform some mathematical operation on arrays. For example, if I copy it and add 10 to numpy array, my array, and then run it, you'll see all the elements of numpy array are added with value 10. Similarly, if I multiply it by, let's say, 2, then we'll see all the elements of numpy are multiplied by 2. And this feature is called broadcasting in numpy. We can also use numpy to calculate mean. And you can see it has calculated the mean of 1, 2, 3, 4, 5, which is 3. Now let's use another package which is used very much in machine learning application, which is called panda. So we'll import pandas as pd. Just run it to check whether it exists. So panda is a powerful and widely used open source Python library for data manipulation and analysis. It provides easy to use data structures and data analysis tool for handling structured data such as table and time series. Let's use panda module to create a data frame or a table from a dictionary of list. Let's say my data is a dictionary which has element name as key, which is associated with a list and David. Similarly, it has another key age, which is associated with list of integers. Use comma over here. And then finally the key gender, which is associated with values female, male, and female. So to convert this into a Python data frame, we'll use my df as a variable, and we'll call pandas function data frame with the dictionary my data, and then we'll print my data frame. And when we run it, we'll see our dictionary is converted into a beautiful tabular format with header, name, age, and gender, and the corresponding entries to that. We can use pandas module to perform some operation on data frame also. For example, let's just print the name column using the subscript operator, and we'll get this name column. Let's just comment these two, and then let's just print the content at location 2. It gives me the third row of the content. We can also check describe, which will describe the data frame in terms of number of entries, what is the mean, standard deviation, what is the minimum value, and all those things. That's it about how to use third-party powerful modules and packages in Python. To create our own modules and packages in Python, we need to write our own Python code, such as variables, functions, classes, etc., and save them in a file or a folder with a .py extension for modules and a __init__.py file for a package. For example, let's create a simple module that contains a function that calculates the area of a circle and save it as a circle.py in the same folder as our main program. So in the same folder as our main program, we'll create a new Python file and name it as circle.py. And in circle.py, we'll write the following code. Over here, first we are importing the math module to use the pi constant, and then we'll define a function that takes the radius of the circle as a parameter and returns the area. We are returning the area of a circle by using the formula pi r square. To use our own module, we need to import it using the import keyword or from import syntax, and then use its content such as functions, classes, variable, etc. For example, let's import the circle module and use its circle area function in our main program. So we'll first import circle and then use circle module circle area function that we have defined in circle.py with the parameter 5, and then we execute it and we'll get the desired area of the circle of radius 5. To create our own package, we need to create a folder that contains one or more modules and a _init_.py file. That indicates that the folder is a package. The init file can be empty or it can contain some of the code that is executed when the package is imported. For example, let's create a simple package that contains two modules, circle.py and rectangle.py, contain functions that calculate the area and the parameter of circle and a rectangle. And let's save them in a folder called shape and create an empty _init_.py file in the same folder. So let's just create a folder with the name shape, and inside this shape folder, let's create first _init_.py file. So this can be an empty file or it can contain some import functions that are loaded when the package is loaded. This also indicates that this shape folder is a package. Let's just save the file. Then inside the shape directory, we'll create another file called circle.py. The circle.py contains the following code. So first, it will import the math to use the pi constant, and then we'll define a function which takes the radius of a circle as a parameter and returns the area. Area is again returned by calculating pi r square. Then we are also defining a function that takes radius of a circle as a parameter and returns the parameter. The parameter is calculated using the formula 2 pi r. Next, in the very same shape folder, we'll again create a rectangle.py file which has the following code. So first it will have a function that takes length and width of a rectangle as a parameter and returns the area by multiplying length into the width. And similarly, another function that takes the length and width of a rectangle as a parameter and returns the perimeter using the formula 2 into length plus width. To use our own package, we need to import it using from import syntax and then use its content such as functions, classes, and variables. For example, let's import circle module from the shape package. So from shape import circle, and then we'll print circle dot circle area 5, and if we run it, it will give the desired output. Similarly, we can print the circle perimeter with the radius 5, and we'll have the output of the area and perimeter of the circle of the radius 5. Similarly, we can import rectangle also and print rectangle dot rectangle area of size 10 by 6, and then we can print the rectangle dot rectangle perimeter of the same rectangle of size 10 and 6, and when we run it, we'll get the output of the area of the rectangle of the length and breadth 10 by 6 and its perimeter. This concludes our session for today, where we have learned all about modules and packages. In the next episode, we learn about errors and exceptions in Python. If you found this helpful, don't forget to like and subscribe to Sumantra Codes for more Python tutorials. Drop any questions in the comments below, and happy coding once again.